Hi, in this video we're going to plot a quadratic graph and we've got it in factorized form like this. Now, we know a quadratic graph, when we're plotting them, they either had this shape here, like a smiley face shape, or a hill shape like this. And what makes it a quadratic graph is that if we were to expand this out, we would have an x squared term. The 2x times the 2x is 4x squared. It's got an x squared term, so it's going to be a quadratic. And it's going to have one of these two shapes. Now, always the thing we should start with is to find the x and the y-intercepts. So where does this graph here cut the x-axis and the y-axis? So, and the way we do that is to say, well, when we're on the y-axis, the x value is 0. And similarly, when we're on the x-axis, the y value is always 0. Look, if we look here, the y value is 0. If we look here, the y value is 0, etc. So let's find those points first. So we're going to say, let's just copy this down here first. Y equals 2x plus 3, 2x minus 5. So firstly, to find the y-intercept, we're going to make x 0. So when x is equal to 0, we've got y is, and then if we substitute that into this equation, we're going to have 2 times 0, which is 0 plus 3, which is 3. So that first bracket is 3. And then we're multiplying it by the second bracket. It's that times that. Well, when x is 0, we've got 2 times 0, which is 0. Subtract 5 is minus 5. So we're going to have minus 5. And that is negative 15. So when x is 0, y is minus 15, which is going to be here. That's x is 0, y is minus 15, right? Okay, so we've got the y-intercept. What about the x-intercepts? Well, that's when y is 0. So when y is 0, then if we make y 0 in this, if we make y 0 in this here, then we've got 0 equals 2x plus 3 times 2x minus 5. Now remember, when we have a product of two things is equal to 0, then at least one of these two things has to be 0. So if it was the 2x plus 3 that was equal to 0, then if we subtract 3 from both sides, we get 2x is negative 3. And we divide both sides by 2, we get x is negative 3 over 2. So that's one of the solutions. And remember, the quick way to solve this is equal to 0 is that we negate the number without the x. So we negate the plus 3 to become minus 3. We change the sign. And then divide by the number from the x. So it's minus 3 over 2, which is what we've got here. And then we do it the quick way with this other one here. We negate that. That becomes from negative 5 to positive 5, and then you divide it by that 2. So x is positive 5 over 2. So when x is either of these values, that makes y 0. So let's plot these up here. So we've got x is minus 3 over 2, minus 1.5 is here. That makes y 0. And then also when x was positive 5 over 2, y was 0. 5 over 2 is 2.5, which is here. Okay, so we've now got our x-intercepts, also known as roots, and the y-intercept here. And then we would be able to plot the quadratic that goes through them. Now, as we said earlier, like either the quadratic is going to be a smiley face shape or it's going to be a sort of hill shape. Now, if it's got to go through these 3 points, it's got to be the smiley face shape, right? Also note that if it's going through this point and this point, because a quadratic graph is symmetrical, basically halfway between these 2 points, so halfway between these, which is going to be sort of around here, that's where the lowest point of the graph is going to be. So now let's just kind of roughly approximately draw it. It's going to come down, get to the bottom, and then coming up like this. And that's going to be what your graph looks like. If you're doing this on the platform, then you should be able to drag these control points to here, here, and here, and it will draw the kind of graph through those 3 points for you.